Morning everybody, hope you're okay. Here we are ready for some more maths. Let's start off with another Fab 4 warm-up. So pause your screen, a little bit like yesterday. I've done the similar pattern so you can have another practice. 4 questions, 4 minutes, pause it, off you go. All right, so then I'm not going to take ages going through these today because I want to crack on with our lesson, but hopefully for the first one you will have thought about your layout, so you will have set it up a little bit like this to do your takeaway, and you should have got an answer of 14.57. 2.3 times 1,000, this is really important at the moment because we're doing our converting units, so hopefully you would have got an answer of 2,300. Now 99% of 200, lots of different ways that you can think about this one. Now if I'm working out 99%, I always think to myself, well, what's 1%? Well, 1% is if I do 200 and I divide it by 100. And that would give me an answer of 2. And that's the same as 1%. So if I want to find out 99%, I know that this whole amount here of 200 is worth 100%. So if I just take away 1% from 200, so I need to take away 2, I will get an answer of 198. That's a really quick and easy way of working out 99%. Find 1%, take it away. And finally then 2 fifths add 0.06. Well, I thought about the fact that 2 fifths is the same as 4 tenths, which is the same as 0.4. And then I had to add it to 0.06, so I should have had a final answer of 0.46. Okay, so what are we learning today? Now, today we're going to be doing some word problems involving metric units. So our will is to be able to convert between different units of measure, really important for today, to make units the same to answer word problems accurately, and to be able to answer 1- and 2-step word problems. So for our first little bit, I wanted to have a quick recap of things that we've learnt. So you'll see that popped up on the screen, capacity. This is when we're looking at liquids, how much containers can hold. 1 litre we know is the same as 1,000 millilitres. So half a litre, 0.5 litres, is the same as 500 millilitres. Mass, look at how heavy things are. We've got 1,000 grams in a kilogram. So in half a kilogram, we've got 500 grams. And length, this is the one where we've got lots of different units to look at. Now, the first ones up here, these tend to be distance, long distance. So kilometres tends to be when you're looking at distance that you may be driving between places. If I'm going from Dunkirk and I'm driving into town, that I would maybe measure in kilometres. Then you go into metres, which may be the length of the classroom or the playground. That would be the length of metres. And then you've got centimetres and millilitres, which may be smaller objects that we might measure. Now, I wanted to put these up here so that you've got this as a point of reference for today. So if during your work in your book, you think, oh, I can't remember how many metres there are in a kilometre or how many centimetres there are in a metre, that kind of thing, I want you to be able to come back to this screen and take a look. I've just realised that this here shouldn't say centimetres, this should say millimetres. Apologies, that's my typing error. So that should be 1 centimetre is the same as 10 millimetres. So this screen here can really help you to come back and think, yes, oh, look, here we go. I'm converting millimetres into metres. There are 1,000 millimetres in a metre. You can use this to help you for today. So our first discover, we've got 3 children here in the greenhouse. We've got Bella, Rena and Richard. They've all got watering cans that hold different amounts. So Bella says hers holds 1.4 litres. Rena's holds 1,250 millilitres. And Richard is saying mine holds half as much as yours, Bella. And there's a big container here you can see that's got a big total of 4 litres of water that they can use to fill up their watering cans from. Now, our first question is, how much more water does Bella's watering can hold than Rena's? Now, the most important thing I want you to take from this online lesson is that when you're working out word problems, you need to make your units the same before you calculate any answers. So when if we look at this question, let's circle the important parts. We're looking at Bella's watering can and we're looking at Rena's watering can. Now, Bella's watering can holds 1.4 litres, okay? And Rena's watering can, she says hers holds 1,250 millilitres. Now, bearing in mind what I've just said, the units are different, so we can't calculate it. Now, it's often easier to turn these into the smaller units, because often if we're dividing or we're taking away, it does make our life a little bit easier. So in this case, I think what we need to do is we need to convert Bella's 1.4 litres into millilitres. Now, let's just remember, we've got 1 litre, we've got 1,000 millilitres. So we're going from the larger units of litres into the smaller units of millilitres. So we're going to have to this time times by 1,000, aren't we, to convert here. Now, maybe down here it might be helpful if I were to write myself a place value chart. So I've got my thousands, hundreds, tens, ones and tenths, and I'm going to put 1.4 in there. Now, if I'm timesing by 1,000, I've got 3 zeros, so everything's jumping 3 places larger. So 1, 2, 3. My 1 is going to come into the thousands. My 4, 1, 2, 3 is coming into the hundreds. And then remember, I've got 2 gaps. I've got a gap in the tens and I've got a gap in the ones. So I put a place holder of a 0 in those spots. So I know that 1.4 litres is the same as 1,400 millilitres. Now, I can now compare Bella and Rena a lot more easily, because if I write it over here, Bella has got 1,400 millilitres, Rena has got 1,250 millilitres. So then we can look at this bar chart. So the question is saying how much more water. So if I've got 1,400 and 1,250, what type of calculation am I going to do to work out what's missing? Well, I would do a takeaway. So I would do 1,400 take away 1,250. Okay, so 0 take away 0 is 0. I can't do 0 take away 4, so I'm going to borrow from next door. 10 take away 5 is 5. 3 take away 2 is 1. 1 take away 1 is 0. So that means that in this spot here, I get an answer of 150 millilitres. So that means how much more water does Bella's watering can hold? It holds 150 millilitres more. How could I check that answer? Well, I could do the inverse, couldn't I? Because if I added 150 millilitres to Rena's 1,250 millilitres, I should get an answer of 1,400 millilitres. Okay, so next part of our think together, it says, if the children use the water from the container to fill their watering cans, how much water will be left in the container? Right, so I've got to think here, because this is a little bit more two-step problem, isn't it? So first of all, we need to remember how much everybody has. So Bella has 1.4 litres, Rena has 1,250 millilitres, and Richard says mine holds as half as much as yours, Bella. So before we do anything, we need to put these all into the same units and figure out how much everybody has. Now, we've already done it on the previous slide. We know that Bella had 1,400 millilitres. We converted our litres into millilitres, didn't we? Rena, was already in millilitres, has 1,250 millilitres. Now, Richard has said, mine has half as much as yours, Bella. So that means Bella has 1,400 millilitres. It's got half as much. We need to divide that by 2. So that means that Richard has got 700 millilitres. Now, in order to find out how much water they're taking out of that 4 litres, we've got to add those together, haven't we, to see how much water they're using all together. So I'm going to do here a sum and add those up. So I've got 1,400 millilitres, 1,250 millilitres, and 700 millilitres. Maybe you could pause the video and see if you get the same answer as me. So I'm going to add those together. 7 add 2 is 9, add 4 more is 13. 1 add 1 add 1. So all together they have 3,350 millilitres of water in their watering cans. Is that the answer though? Is that where I stop? Let's go back to the question, and it says, if the children use water from the container to fill their watering cans, how much water will be left in the container? Now, that doesn't mean my answer is 3,350. That's how much they've taken out. I need to know what's left behind in that container. Now, it says there are 4 litres of water in the container. But I've worked out my answer in millilitres, so what can I do? Well, I think I'm going to think, well, what is 4 litres in millilitres? Well, 1 litre is 1,000 millilitres, so 4 litres must be 4,000 millilitres. Now, in order to see what's left behind, I've just got to take away this from 4,000, haven't I? So I'm starting with 4,000 millilitres. With all the watering cans combined, I've taken away 3,350 millilitres, and this is going to give me my answer. So 0 take away 5 I can't do, so I've got to carry from here. It's going to be a 9. So 10 take away 5 is 5. 9 take away 3 is 6. 3 take away 3 is 0. So what is left behind in the container is 650 millilitres. Now, if you really want to stretch your brain, maybe you could have a go at converting that back into litres. So if I want to go from my small unit to my large unit, I've got to divide by 1,000. So see if you can write it down before I do. This in litres is the same as 0.65 litres. So you could write your answer in either form. Lots to do there. You've got converting, you've got to add together, you've got to find the difference. Real brain stretching work. Let's have a look at our first think together. So the water carrier contains 3 litres of water, but 600 millilitres of water has leaked onto the floor. How many millilitres are left in the water carrier? Now, these are always going to try and catch us out by looking at different units of measure. So this one says 3 litres of water to start with, but 600 millilitres falls out. And this wants us to tell us how many millilitres are left. So the first thing I've got to do is think, well, if it's in millilitres, I need to convert my litres into millilitres. So let's remind ourselves, 1 litre is 1,000 millilitres, isn't it? So I've got to do 3 times 1,000 to work this out into millilitres. So this means that is 3,000 millilitres of water are held in the container. Now, if 600 millilitres leak out, I've got to take that away from my 3,000 millilitres. Now I'm going to see if I can do that in my head. I'm going to start at 600, count onto my next whole litre, which I'm going to add 400 millilitres, and then I've got 2 more litres of water. So actually left behind is going to be 2,400 millilitres of water. Okay, for those ones that have got your brains really switched on, can you put that back into litres? So 2,400 millilitres would be the same as 2.4 litres. But our final answer they wanted in millilitres would be here. That's just to see if you can do your conversions again quickly. All right, number 2. So this one here, 4 kilograms of compost is divided amongst 5 trees. How many grams of compost will each tree get? Now we can do this 2 ways. We could think, well, 4 kilograms of compost, I'm going to divide that by 5, okay? And that's going to give me in kilograms how much compost they get each. Now, what I could do, because if I think, well, I'm a bit not sure about dividing 4 by 5, it's decimals, it's a bit hard, I could put that 4 kilograms into grams. So I could think, well, 4 kilograms, I'm going to times it by 1,000, okay? And that would give me 4,000 grams, wouldn't it? Okay, now, then that's going to be a little bit easier, I think, to divide, because look, here's my 4,000 grams. I could then do a lot more easily 4,000 divided by 5. So 5s into 4 don't go. So I carry my 4. 5s into 40 go 8. Nothing, nothing. So that means that 4,000 divided by 5, sorry, that should have a 0 on it, gives me an answer of 800 grams. So each tree will get 800 grams of compost. So for those of you really wanting to push yourselves, what would that be in kilograms in case we wanted to convert it? Well, I would divide that by 1,000 and that would give me 0.8 kilograms. It's always really good to keep your brain trying to switch either way from one unit to another, because it really just gets you practicing and understanding how it works. Finally then, our last think together. A garden hose is 8 meters long and a flower bed is 9.2 meters away from the water tap. The hose is too short. How many centimeters longer does the hose need to be? Well, first of all, our calculations are actually both in meters. So if I picture this in a diagram, because sometimes I quite like to see it as a picture. So here's our hose, okay, and this is 8 meters long, okay, but the tap is here, all right, our tap that's got the water coming off it, where we need to fix it onto, is here, and this is 9.2 meters away, okay. Now that means that there's this little gap here that's too short. So how many centimeters longer does the hose need to be? Well, first of all, I'm going to think, well, I'm going to work it out in meters because that's nice and straightforward. Because in order to find out the difference between those two, I've got to do 9.2 and take away 8. And that would leave me with 1.2 meters. Happy with that? That's then telling me that here, this needs to be 1.2 meters longer in order for it to reach the hose. And I know that's correct because if I did 8 add 1.2, I would get an answer of 9.2. But crucially, my question wants my answer to be in centimeters. So that means how many centimeters longer does it need to be? So 1.2 meters is how many centimeters? Well, let's just think what I know. I know that 1 meter is the same as 100 centimeters. So I'm going from my larger unit to my smaller. So I've got to times this by 100. So everything's jumping 2 places larger. So that means 1.2 meters is the same as 120 centimeters. So how much longer does the hose need to be in order to reach it in centimeters? Our answer would be 120 centimeters. Okay, so there's lots of different things to think about when you're problem solving. You've got to understand what the problem wants you to solve, and you've got to then make sure your units are matching. So you've got to remember all of those conversions, put them into the same units before you tackle the question. That is the most important thing for today's work. Now, you're working in your books between pages 106 and 108. If you're usually, when we're normally back at school, if you're in my maths group, I want you to focus on questions 1 to 3, okay? If you feel that you're really understanding it, please go on and do the rest and have a go. The rest of you have a go at seeing if you can get to the very end of the challenge. If you do all of that really easily, I will leave, as always, this challenge here that you can come back and tackle. Any questions, please send me a message to the dojo. Good luck, and I'll see you tomorrow. Take care. Bye-bye.